I am so happy to be here. Again, welcome to USC. It's so great that I got to follow Dean Yorksos. So together, Dean Yorksos and I are the deans of engineering, and I'm the dean of college letters, arts, and sciences. So we've got science, math, and engineering. We got it covered. We're so happy to have you here. I am going to talk to you about something which is one of my favorite things in the universe, which is the James Webb Space Telescope. Oh, this is good. Okay, and this is why I think it's so cool, because you see the title here, it's the science and engineering marvel that is the James Webb Space Telescope. It brings together what I think is perhaps the greatest engineering marvel of our generation. I think it rivals the Great Pyramids. I think it rivals the Panama Canal. It really is a civilization-defining achievement, what we've done with this telescope. So I want to talk to you about that. And I want to talk to you about the crazy, incredible science that it's revealing all the time. I'm also very excited to show you a lot of really cool pictures, like this one. Before I even give my talk and talk to you all about exactly how this telescope happened, I want to lead with a picture. This is my favorite picture from the James Webb Space Telescope. This is an image on a tiny little spot of the sky. So imagine you take a grain of sand and you hold it at the length of your arm, and you imagine how much of the sky that covers. That's the size of this image on the sky. It's a completely dark region of the sky, but when you look deep enough with a big enough, most powerful telescope, you receive an image like that. You're seeing so much here, I'm going to give you just a glimpse of it. The big white balls of stuff that you see kind of in the middle here, like right in the middle, that's a massive galaxy cluster. That galaxy cluster is 4.6 billion light years away, with a B. And one of the cooler things about this image is, do you see these little arcs? Can you see the arcs of red that are kind of around the middle? Clap if you can see little arcs. Anybody know what that is? Gravitational lensing. Very good, very good. So that is these are distant galaxies that are even farther away than that. Their light is shining past this really massive cluster, and through gravity, general relativity allows us to understand what's going on. The light is bent like a lens into these funky shapes. And from the shapes, we're able to extract things like how much mass is between us and that galaxy. And this is one of the reasons why we know something called dark matter exists, because of this kind of really cool curves. So it's a really cool looking picture, and there's a lot of science in this picture. I'm gonna ask you some questions. Who has heard of the Hubble Space Telescope? Make some noise, don't raise your hand, make noise. Good. Oh yeah, okay, there we go. Who's heard of the Webb? I think we have. Let's go, make some noise. Okay, that's not loud enough. Who's heard of the Webb, the James Webb Space Telescope? Okay. So if you compare these two, Hubble was a telescope that was launched when I was about your age. And wow, I know, it's like an antique. And it's up there, it's still up there, but it's much, much smaller than Webb, and it's a different kind of telescope than Webb. So this compares the two. On the y-axis here, it's kind of how much light gathering power a telescope has. That's kind of how big of a light bucket it has. That's a measure of how powerful it is. And then on the other axis is the wavelength. So what's going on with Webb is it's much, much bigger. In fact, it's 6.5 meters in diameter. And if you look closely at this picture, there's little images of people. That's how big a person is compared to Webb. And so its light gathering power is tremendous, and it's also looking at light in the infrared. So it's really this kind of incredibly large and powerful telescope that's out there. Where is it? Anybody know where it is? You can shout it out. L2, I love it. I love this audience. Wow, I tell you what, this is good. You guys should all apply to USC. That's right, it's an L2. So this telescope, which was launched about 5 years ago now, 5.5 years ago now, took about 6 months to get out to L2. L2 is a special orbit. It's called a Lagrange point 2, and it's a place where the gravity from the Earth plus the sun tugs on it just a little bit extra, and this is a place where it's orbiting in line with the Earth. So you can see in this movie, another thing is, this thing has a big, what's called sun shield. And so the telescope is faced away from the sun. The sun shield blocks the sun, and it keeps the telescope cold. And in fact, on one side of the sun shield, it's 185 degrees Fahrenheit. It's very hot. But on the other side of the sun shield, it's about 50 degrees Kelvin. So it's hundreds of degrees difference in the temperature from one side to the other, and it's totally passive. It's just the engineering of the shield that blocks it. So there's all kinds of incredible engineering going on. Not only did we put this telescope precisely at L2, but it's folded out into this incredibly large gold-coated mirror, and it's out there doing tremendous science. Now, given how cool this thing is, how tremendously incredible the engineering was, it took 20 years to build, almost flawless execution. Does anyone know where it was built? Let me ask you a question. Is there anybody here from Texas? Let me ask one more time. Is there anybody here from Texas? Okay. Is there anybody here from North Carolina? Huh. Is there anybody here from Georgia? Okay. Is there anybody here from California? Okay. I could keep doing this, but they're going to kick me off the stage. So I'll just tell you, every state in the United States contributed to building this telescope over 20 years. Let's go. That's cool. But there is a special thing about where we are now, because the prime contractor, the final institution that put this thing together and tested it, was Northrop Grumman here in Redondo Beach, California, not very far from here. I got to even visit this thing before it launched. I snuck in there. They didn't catch me. I didn't break anything. And then it was launched December 25th, 2021, into this incredible thing. Now, we spent all this time building this incredible telescope. Why did we build it? Anybody know why we built it? To look really far. That's good. That's a clean answer. I like that answer, to look really far. It's pretty complicated. So let me tell you a story of why. One reason is we want to understand how we got here. And I mean this in the broadest, most fundamental sense. We have a model of the universe right now that we think we understand quite well. When space and time itself, as we understand it, began 13.8 billion years ago in an event that we call the Big Bang. We call it the Big Bang because we don't have a better name for it. It didn't make a sound. It wasn't that big, but it was this event. And the universe has been expanding and cooling since that time. In the beginning, it actually started off with almost nothing but hydrogen and helium. And incredibly hot, almost perfectly smooth. There was no structure in it. But over time, structure formed. And we know that this has happened. Now we have galaxies and tremendous structure everywhere. And in one of these galaxies, at least one, there was one planet, at least one of the 100 billion or so we know of in the galaxy, that had enough liquid water and the right conditions that we're still trying to understand to end up with complex atoms. The thing I should say, of course, is that although we started out with hydrogen and helium, it's stars that fuse the heavier elements together. And along the way, in the hearts of stars, carbon, nitrogen, oxygen, phosphorus, other important elements that make up our DNA. And now we have these things, these people, these entities on this planet that can now look back up at the stars and try to answer these questions. And in that sense, we are the universe understanding itself. And I should say that's a tremendous responsibility. So keep trying to understand. The other thing is, we understand this, but there's a lot of stuff we still do not understand. So for example, we really don't understand what the universe is made of at all. About 25% of the mass energy density of the universe is in the form of something called dark matter, which has gravity, but we don't know what it is. And 70% is in the form of something called dark energy, which is driving the universe to accelerate in its expansion. But only 5% of the universe is anything in the periodic table. The whole periodic table, just 5% of the universe. So we have a lot to understand. And this is why we built machines like this and try to understand what's going on. So I can't stand up here all night. I could show you pictures all night and talk about them, but what we're gonna do instead is we're gonna play a game. You're gonna get to pick which image you wanna talk about. So there's two really cool images here. One is the Pillars of Creation, and the other is called Phantom Galaxy. It's a galaxy that we call the Phantom Galaxy. So what we're gonna do is we're gonna see which one gets the most noise. So who wants me to talk about the pillars of creation. All right, okay. All right, Phantom Galaxy, you got your work cut out for you. Who wants to hear about the Phantom Galaxy? Hold on a second. I gotta ask Dean Yorksos who won. Who won? All right. Okay, the judges say Phantom Galaxy. All right. I'll just say there's really cool stars forming here. This galaxy, this is an incredible picture for lots of different reasons. This thing is 32 million light years away, and it's about the same size as our home galaxy. It's about 100,000 light years across. This thing is like I said, about the size of the Milky Way. And the coolest, I mean, this thing is just beautiful, but one of the most astounding things about this from an astrophysicist point of view, people who try to understand gravity, or understand galaxies, is you see this kind of bubbly structure. It almost looks like there's bubbles throughout these spiral arms. Those are bubbles that are blown by supernova blowing off. So a heavy star ends its life, explodes, and then blows out gas all around it and actually makes these pockets. And by seeing how many pockets, how many open spots there are, that's telling you how often stars are exploding in this galaxy. Another thing that's incredibly cool is the very middle, which is blue. This blue empty region is fascinating, and there's a lot of extremely young stars. So there's a lot of stars forming like crazy in the middle of this galaxy. So these are the kind of things that just from looking at the image, you can understand the physics of what's happening as we try to understand how galaxies like this emerge. To give you a sense of how big this thing is, if you took a galaxy like this and shrunk it down to the size of the Pacific Ocean, the size of a star in that galaxy would be the size of a piece of pollen on a maple leaf in the ocean. And the nearest solar system would be about a mile away on another leaf with its own solar system. So that's how large this galaxies like this are, and it contains billions and billions of stars. So the last thing I want to end with, I'll have time to show one more picture, and it's talking about what we're really doing with Webb to kind of push the frontier of discovery. This is an image of about the same size, a couple of grains of sand lined up in the night sky, incredibly dark, and it's a deep image. So it's a place where this telescope is pointed at one spot effectively for weeks. And then effectively like opening the camera shutter and just collecting light. It's been collecting light for weeks in this giant telescope pointing at this region of the sky. And this is a particularly special region because in this region, in this picture, is the most distant galaxy yet detected. This is it. So this galaxy is called MOM Z14. The astronomer named it, you guess it, after his mom. This thing existed when the universe was only 280 million years old. So the universe is 13.8 billion years old. This thing existed when the universe was 280 million years old, and it is currently about 34 billion light years away. The reason why it's 34 billion light years away, which is older than the age of the universe, 13.8 billion, is because the universe has been expanding since the light left it. So that's why it's 34 billion light years away. And one of the astounding things about this galaxy is, first of all, it's very small. It's about, it's about 100 times less massive than the Milky Way itself. But more profoundly, we're looking at this object, as it were, of course, before the Earth existed. This was way before the Earth existed. But more than that, we're seeing this galaxy as it was before the carbon atoms in your DNA existed. So the atoms that build the scaffolding of life did not exist when this galaxy was glowing as we're taking this picture. We are looking way, way back in time. And we can learn things about, we actually see elements forming. We can see it from the spectra of this galaxy, that we can see elements being made in this system. These are some pretty profound things, right? And in fact, a universe that is this old, this large, and this profound can sometimes make people feel small. Do any of you feel small, maybe? It's good. I like the quiet, not cheering. If you feel that way, I want to remind you of something. You're a member of the species that figured this out. And we have a lot more figuring out to do, and that's your job. And whether it's about the makeup of the cosmos, the origin of the universe, quantum computing, new kinds of materials, building next generation technology that improves lives and saves lives, whatever it is, keep doing it. You represent the best of us and the best of our future. Keep going. And with that, let me just say thank you and fight on.